Hello, friends, and happy Halloween. Today we are going to use what we already know about evaluating expressions and apply it to something that looks like this. Weird, right? Well, not too weird. You already know how to do this. How do we get rid of those parentheses? PEMDAS, order of operations, say, you must do this first. And we're like, I know, but I do know something about parentheses. I know I can get rid of those and keep on simplifying if I distribute this term out here. So let's distribute first and be like, PEMDAS, you don't even know. I do what I want. So negative 2 times 3x is negative 6x. And negative 2 times positive 4 is negative 8. And then we're just going to bring back down that positive 12 because it's a plus 12. It is not getting distributed on by this negative 2. It's not part of the parentheses. Each one of these terms gets to have a negative 2 multiplied, but not the 12. And now we use whatever strategy that is our favorite to separate those terms so we can tell which ones are alike. So we just have negative 6x, and then we're going to put together positive 12 and negative 8, which is positive 4. Yeah, it is. And that's our answer, correct? Well, what if we had something that looked like this? Again, you've seen these before. You know what to do. This means subtract this entire expression, this entire quantity. But PEMDAS says, meh, you can't minus those because you have to do all this first. But we do know, how many of these do we have? Well, just one. Well, really, we have negative 1. We can put a 1 in there, or we can distribute the negative to each of those terms and drop this parentheses. It's fantastic. So, tricky. Negative 1 times 3 is negative 3x, and then negative 1 times positive 4 is negative 4, and then we've got that 12 hanging on at the end. Let me just show you. If you don't like to put a 1 there, that's fine. The opposite of 3x is negative 3x. The opposite of positive 4 is negative 4, or minus a positive is just minus 4. Minus a positive is just minus 3x. So it depends on how you're looking at that. Then separate your terms to find out which ones are alike. The negative 3x is by itself, and then positive 12 and negative 4 is going to be, ouch. Sorry, I feel like something just bit me. 8. So we've got positive 8. All right, so you can do that. But what about this? Think for a moment. What do you know over here that you can do here? PEMDAS says you can't just drop those parentheses and keep going. You can't just write 6x plus 3 minus 2x plus 2, because you're actually subtracting each term that's in here. But what did we just do here? We distributed to get rid of those parentheses. And when we had a negative here, we just pretended like it was a negative 1. Well, what about this one? Is this a negative or a positive 6x plus 3? That quantity is positive, correct? Usually the first term, if it's not negative, we know it's positive there. And how many of these? We have a 1 of those. And we have 1 of these. So I'm going to kind of do these in different colors. If we just go ahead and distribute a positive 1 to this, which essentially is just in our mind saying, I can drop the parentheses. 1 times 6 is 6x. 1 times 3 is positive 3. Drop the parentheses on that. But over here it's a little bit different. This one we've got negative 1, and we're going to distribute this to both terms. Negative 1 times 2 is negative 2x. Don't worry about minusing a negative or doing something funky. Just write down that term, negative 2x, because negative 2x, adding that is the same as subtracting a positive 2x. So here we go. Negative 1 times negative 2 is negative 2. So just write that down. So I have different colors because I wanted you to see this negative 1, or this minus 2x plus 2, really became negative 1 times the quantity 2x plus 2, which is negative 2x minus 2. You kind of did the opposite of 2x is negative 2x. The opposite of positive 2x is negative 2x. Boom. Okay? Or minus 2x minus a positive, which is just minus 2. So let's go ahead and use, I like the line strategy because I already see the terms when there are x's and when there are not, and some of you are getting to the point where you don't have to box and bubble so much because you know you're going to put the x's together. You don't need to look for a box to do that, and that's fine. So you can graduate to slowly to using different strategies. This is a 6 and a negative 2x. You might think of it as 6x minus 2, that's fine, or 6x plus negative 2. They both equal 4x, so not a problem. And then we're going to combine, those two are done. We're going to combine negative 2 and positive 3, which is not 5, it's not negative 5, it's positive 1. So please use your calculators to check your work. It's been a while since we've done a lot of integer work, and you don't want to miss these problems because you aren't adding and subtracting and multiplying and dividing integers properly, okay? So that's this one. What if we have just a plus like this down here? What we've been doing is this. We're using the distributive property, right? It states that we can multiply any sum like this, distribute it to the inside, and it becomes these things. And so we can use that to our advantage to get rid of these parentheses, because this has parentheses, this doesn't, right? And then the associative property says we can move those things all around and do them in any order when we're adding. So really, this associative property here tells us it doesn't matter what order we're doing it. We can reorganize the whole thing, okay? But we can also think of it as distributing a positive to keep with our former theme. So we can just do 2x plus 3. And this is x plus 4, positive x plus 4. And then we're going to go ahead and divide those, okay? So divide them up into the, terms that have an integer and a number, and sometimes a variable. So 2x plus 1x is 3x, 4 plus 3 is 7, so that's going to be 3x plus 7. In other words, we're just dropping the parentheses and doing it in whatever order we want. When it's addition, it's fine. We can do that, right? When it's subtraction, we really have to use that distributive property to make sure we're minusing, because we're minusing each one, all right? So let's take a look at this back here and do a couple of examples. Let's do the first two together, and then I'm going to have you try 3, 4, 5, and 6, and you can come back and see how you did. All right, we got a minus here, so I do need to distribute that out. So I can just do 6x plus 3, and then this is negative 1 times 2x, which is negative 2x. Negative 1 times negative 8, which is positive 8, right, friends? A negative times a negative is a positive, or minus a minus, okay? And then let's go ahead and separate these into the separate terms and combine our like terms. That is 4x, and this is 8 plus 3, which is positive 11. All right, this one over here, we don't really have to do much because, well, these are subtracting. We do have to do those in order. So we can distribute a positive here. So we have 2x minus 4 plus 3x minus 7x, or 7, excuse me, just drop those parentheses. And let's go back and go ahead and do this and combine like terms. So 3x plus 2x is positive 5x, and negative 4 plus negative 7 is a bigger negative. That's negative 11. All right, go ahead and pause this video and try the next ones. And when you are done, check to see if you did them the way that I've done them. And hopefully I won't make any errors. All right, this one is just 2x minus 1. And I'm going to distribute the positive, which is just plus x minus 5. And then I'm going to go ahead and combine the like terms. So I have 2x and 1x, which is 3x. Negative 1 and negative 5, which is negative 6. If you did not get that, pause and go back and fix it, okay? This one over here is 6x minus 10. This is a negative 1, and I'm going to distribute that out. So negative 1 times 2x is negative 2x, or minus 2x. Negative 1 times positive 4 is negative 4, or minus 4. And then go ahead and combine your like terms. 6 plus negative 2 is 4x, positive. Negative 10 and negative 14 is negative 10, negative 4. My brain already combined those is negative 14. Let's try these. These are looking like a lot of minuses. So negative 4x minus 7, that just stays. And this is negative 1. Let's give it away. Positive 5x. Why? Because a negative times a negative is a positive. Positive 2. Why? Because a negative times a negative is a positive. Minus a minus is actually adding. Minus a minus is actually adding. So let's go ahead and separate those up. Negative 4 and positive 5 is just x. You can write a 1 if you want, but it is redundant. We know that there's 1 there. Negative 7 and positive 2. 7 minus 2 is negative 6. No. Negative 5. Sorry, I don't like how that looks. Negative 5s, because 5, 6, 7. Okay. X minus 5. This one, 2x plus 4. Distribute that negative. Negative times a negative is a positive x. Negative times a positive is a negative 5. And let's go to town combining these like terms. That's going to be 3x, and that's going to be negative 1 because the negatives win. If I go over on the number line to 4 and then backwards 5, I'm going to end up with negative 1. All right, so we can use these and apply these to some word problems. So this hat store is going to sell some college and professional team hats for lots of months, for M months. And the number of college hats sold is this, and the number of professional hats sold is this. So they say write an expression to show how many more college hats were sold than professional hats. When they say how many more, that's minus, friends. So college hats are what we start with, 6M plus 3 minus 5m minus 2. So we have to distribute this -1 out. So we've got 6m plus 3 minus 5m, -1 times -2 is a +2. And then we're going to combine our like terms and get 6 plus -5 is just 1m. 3 plus 2 is 5. So here's our expression. And then it says, then evaluate the expression if m equals 10. I want you to try that out. Okay, m plus 5. Let's replace that with 10. 10 plus 5. 15. 15 more hats were sold professionally than college, okay? I want you to just pause and give this one a try. All right, the number of runs scored in a team is this. This is the number of runs. The number of runs scored by the visiting team is this. We're going to expression to find out how many more runs the home team scored than the visiting team. Again, subtraction. Home team's first because home team is more, visiting team is less. So we're subtracting these ones. It matters on subtraction what one you put in order, and you have to follow that language. All right, so x plus 7. This is a -1. Let's distribute it. -3x. And negative times a negative is a positive, plus 7.
Teachers and students, please.
And then let's combine these, and I will stop here.
The following students to report to the cafeteria and then to the stage of the old gym: Isaiah Allard, Brooke Brotherton, Kyle Burton, Lucas Butler.
All right, and over
Taylor
here, if it's
Cobb,
x is
Kate
6.
Craig, Matthew Chrysler, Tyler
-12 plus 14 is 2.
Nathan Hepler,
I gotta go. You guys are awesome. Get that homework done and go back and look at this if you need to.